The flashboard gate shown consists of a plain face BD resting in a groove at D and supported by the strut CE, which is pinned at the ends. Neglecting the weight of the gate, determine the force per meter length of crest that must be applied at B in order to cause the gate to collapse. So here is the given figure. We have upstream water surface at level at B and downstream water surface level at C. So for the upstream side face, the height or length of the height of the gate that is in contact with the gate is 6 meters, and since the question is force per meter length of crest that must be applied at B, so we must consider 1 meter width perpendicular to the screen. So since this is 6 and the water surface is flush with the top, then supposedly the center of pressure is 1/3 of the vertical height. It is also 1/3 of 6 because the gate is rectangular. So 1/3 of 6 is 2 meters. So 2 meters from the bottom, or 2/3 of 6 from the top. So 4 meters from the top. So the location of force on the upstream face perpendicular to the upstream face is F1, and its distance from B is 1/3 of 6, or its distance from B is 2/3 of 6 or 4. So that's 2 meters, so that its distance from the strut where the gate, if it will collapse, will pivot, is at C. So its distance from C is 0.4, because CD is also 2.4, because this is an isosceles triangle, isosceles right triangle in particular, 90 degrees at C. So this is CD is also 2.4 minus 2, so 0.4. Likewise, since the water surface is flush with C and the distance CD is 2.4, so the location of the center of pressure in the downstream side is 1/3 of 2.4, or 0.8 from D, or 1.6 from C. 2/3 of 2.4 is 1.6 from C. So this is the centroid of the downstream face in contact with the water, and it is half of 2.4 from C, half of 2.4 from D. So 1/3 of 2.4 is 0.8. So that's 0.8. So its distance from C is 2.4. 2.4 minus 0.8, 1.6. So F1 is specific weight of water. Barred H is, this is 3 meters. So if this is 3 meters, then barred H distance from centroid to water surface in the upstream phase is 3 sine 45, and the dimension of the gate is 1 meter perpendicular to the board by 6. So F1 is equal to 124.86 kilonewtons. F2 is 9.81. Barred H is half of 2.4, so half of 2.4 is 1.2 sine 45, and the area is 1 by 2.4, because the submerged part of the downstream gate is 2.4, so 1 by 2.4. This is 2.4 CD. So F2 is equal to 19.98 kilonewtons. So the force at B must be downward because F2 is small, although the moment arm is 1.6, but it is small. So this is 0.4, moment arm of F1 from C, 2.4 minus 2, so 0.4. Moment arm of F2 from C is 2.4 minus 0.8, so 1.6. And the moment arm of FB in kilonewton per meter times 1 meter, so it is FB is because the total length of the gate is 6 and CD is 2.4, so 6 minus 2.4, this is 3.6, the distance BC. So this is 3.6 cosine of 45, because this is 45. So summation moment about C equals 0. FB times 3.6 cosine 45 plus F2 19.98 times 1.6 then equals F1 124.86 times 0.4. Solving for FB is 7.062 kilonewton per meter. So that's it for this problem.